From what it means to what it could have come from and the entire mystery of it all, join me as we explore how a mysterious burst of gravitational waves hit Earth. I know what you're thinking. Gravitational waves hit Earth? So what? And on the surface, pun somewhat intended, I can see your indifference. Clearly, these gravitational waves didn't affect the Earth in a way that we should worry. As you'll soon find out, the waves themselves were only detected in a split second of time. So why should we care about these at all? The answer to that is very simple. We have no idea where it came from at all. The gravitational wave signal picked up by the Laser Interferometer Gravitational-Wave Observatory, LIGO, and the Virgo Interferometer lasted only 14 milliseconds, and astronomers haven't yet been able to pinpoint the burst's cause or determine whether it was just a blip in the detectors. More than likely it wasn't a blip, because if that was the case, then there would be more of them happening as space and time go on. But it hasn't. So if it wasn't a random thing, then that would mean that it is something more, something greater, and of course, something cosmic. But what could cause gravitational waves to hit the Earth, even if it's just a short period of time, and have us not know what it is? Obviously, that rules out something going on in our own solar system. So for the truth, we must look beyond. Look to the galaxies and systems beyond our own and see what it might have been. With that in mind, what out there in the cosmos might be able to cause such waves to reach Earth? The biggest likely theory is that two massive objects collided with each other out in space. How often does that happen? More than you might think. Never forget, it's a big universe out there, and there are a lot of things running into each other all the time. But in order to create waves like these, it would have to be something massive, like a neutron star or a black hole colliding with a counterpart of theirs. Again, this is something that does happen a lot in space. Neutron stars colliding is actually more common than you realize, but that's another list. But if that's the answer, why is the gravity waves still a mystery? That would be because the gravitational waves from collisions of such massive objects typically last longer and manifest in the data as a series of waves that change in frequency over time as the two orbiting objects move closer to each other, said Andy Howe, a staff scientist at Los Cumbres Observatory Global Telescope Network and an adjunct faculty member in physics at the University of California, Santa Barbara. But this didn't read like that at all. So more than likely, this isn't two neutron stars or black holes colliding, which has been further backed up by the type of signal that has been detected before by those kinds of events. And this was a burst of gravity waves, not a wave of signals like others that have been detected before. Alright, so what's another theory that could tell us what these mysterious waves could be? The second theory is that these gravity waves could be the remnants of a massive star collapsing and going supernova. Not unlike neutron stars or black holes colliding, this happens more than you might think. And going supernova is a big part of the life of a star. We do know that there are stars in the sky right now that are potentially on the verge of going supernova, within tens of thousands of years, roughly. So scientists look to see if any of them were not where they were supposed to be, as well as looking for bright new lights in the sky. One of the biggest candidates for a supernova explosion is the star known as Betelgeuse. This star is in the later stages of its life, and it is already showing the signs of getting close to supernova stage. When the gravitational burst was found, some thought that Betelgeuse had exploded earlier than expected, but it hadn't. The star is still exactly where it was supposed to be, and none of the other candidates appear to have gone supernova either. What's more, the burst still seems a little too short for what we expect from the collapse of a massive star, he said. On the other hand, we've never seen a star blowing up in gravitational waves before, so we don't really know what it would look like. Here's another checkmark in why it may not be supernova box. When a supernova goes off, one of the things that it sends out into the universe itself is neutrinos, tiny subatomic particles that carry no charge. They love to send those out, and after scientists found out about them, they made detectors all over the Earth so that they could go and detect the neutrinos when they came our way. So much so that when a supernova does go off, we'll get readings of the neutrinos about an hour or two before the supernova goes off, allowing scientists and potentially people all over the Earth to look up at the sky to see the results of the supernova going off. But since there weren't any neutrinos detected in this burst of gravity, then it's not likely a supernova going off. Another possibility is that the merging of two intermediate mass black holes caused the signal, Howell said. Merging neutron stars produce waves that last longer, around 30 seconds, than this new signal, while merging black holes might more closely resemble bursts that last around a couple of seconds. However, intermediate black hole mergers might also release a series of waves that change in frequency. And this one didn't change in frequency, not even a little bit. LIGO came across this signal while specifically looking for such bursts, but that doesn't mean that what it found is an intermediate mass black hole merger, Howell told Live Science. We don't know what they found, especially since LIGO hasn't yet released the exact structure of the signal, he added. Given the rather mysterious nature of the bursts, many are wondering if it is possible that the detectors just thought they found something when they didn't. Computer error is a very likely possibility, but as researchers dug into this, it became more and more unlikely. Not because of the signal itself, but because of where the signal was detected. You see, LIGO didn't just pick it up with one of their machines, they found it on three. Three that were in very different places. One was in Washington State, the second was in Louisiana, and the final one was in Italy, which means that this burst of gravity, no matter how small or quick, was picked up by the detectors that were basically across the globe. For all three to detect them at the same period of time means that it really is a solid signal. But of course, that also means that we don't know what exactly made the signal. More theories have been proposed, including the merging of black holes, not the same as colliding, just to be clear, or a supernova collapsing within a black hole, but it's not definitive. None of it is. Which brings us to arguably one of the biggest questions there is. What if the event was caused by something we honestly have never detected before? The universe always surprises us, Howell said. There could be totally new astronomical events out there that produced gravitational waves that we haven't really thought about. I know that this may seem like a cop-out because if we don't know what is causing it, it must mean that it is something we've never found before, studied before, etc. But it's a little more profound than that. You see, despite all of our studies, despite all of our research, despite everything we've done to try and get the universe mapped, the fact of the matter is that we just don't know everything about the universe at large, not even by a long shot. We're still finding out things about our own solar system that shocks and amazes us. We're still learning things about the Earth and the Sun that we were sure we knew about a few decades ago, and yet we don't. So for these gravitational waves to suddenly appear and vanish without us knowing what they are, it's just further proof that we don't know as much about the universe that we think we do. For all we know, there could be something just outside our solar system that caused the event itself. What could it have been? Your guess is as good as mine, but the option is there. Of course, that also means that there could have been something out in the deepest reaches of space that caused these gravitational anomalies. Or there could have been a sequence of events that we never thought probable or likely to happen in our lifetime that caused the gravity waves. We just don't know. And to be honest, that's okay. We don't need to know everything in the universe, because the moment that happens, the awe and wonder tends to go away. After all, if we boldly go where no man has gone before, and then we find all the places we've never been to before, what's left to explore? Now, that doesn't mean that we don't try and figure out what's going on here. That's not what we're saying. We're just saying that it's cool and there are a lot of options as to what these gravitational waves could be. And of course, one of the biggest questions that could happen to come up during these studies and research as to the source is, what if it happens again? After all, this discovery was very recent. It happened in January 2020. And so by that token, it could mean that there are potentially more bursts like this coming in one form or another. And it's also possible that one of these bursts may be a bit more powerful than the one we've detected. What do you mean by that? Well, as noted, the gravity wave burst that we detected was only milliseconds in length in regards to time it hit Earth, which means that technically the Earth was squeezed for that length of time. Now imagine what would happen if a more powerful burst of gravity waves hit us. Ones that would, say, last, a minute or so. If that was to happen, it could honestly have an impact on our planet. How would that work? Well, think about it. In the grand scale of our solar system, our world is held on a tether. That tether is tied to the sun, which exudes its massive gravity to pull all the planets, moons, and other debris and celestial objects in a certain kind of pattern we call orbits. It's true that the moons circle the planets because of planetary gravity, but the sun still helps in its own way. Moving on, that tether is finely tuned and balanced. If something is messed up within that balance, a whole lot of other things will suffer, not unlike if one of the planets randomly disappeared from the solar system. Depending on the planet, it honestly would cause certain problems for the system as a whole. Getting back to the gravity situation, if the gravity wave was strong enough, it could have the potential to disrupt our sun's pull on our planet. Even if it lasts a minute, that's a lot of potential gravity deflection, even if we don't realize it. Think of the solar system as a series of balls in a groove around a circular board. Each groove that each planet is in is their orbit, with a giant ball in the center signaling the sun. If the gravity wave hit the Earth and was able to either pull it out of its groove or halt it in its groove, that would affect the entire way the board works, especially if we're moved out of that groove and thus thrown into another orbit or even a slightly altered orbit. After all, our orbit around the sun helps determine not just the seasons on Earth, but how much heat, light, and radiation we get. So if we were suddenly thrown for a loop, yeah, that would have a devastating impact on our planet. Granted, this is a big assumption, but it's not one that can be discounted since we don't know where the waves came from. Should an event like this happen again and the waves are stronger and stay longer, we could be in trouble. Or in contrast, if the waves continue to come and continue to be detected, we could find ourselves with more clues as to where it all came from. At present, this mysterious gravity wave may not seem like a big deal, but considering we don't know much about the wave itself, where it came from, or where in space it originated from, this mystery is exactly what scientists love to find, because it gives them reasons to look at sections of space they may not have looked at before to see what might be causing this. Should the answer be found, it could help bring even more illumination on how the universe works, and that's something just about every scientist would be up for.